Okay, so this is the last application for some or for the basic plane potential flow. Okay, so as I mentioned in previous lecture, there are four kind of basic plane potential flow. The first one is uniform flow. The second one is source and sink, and then the third one is vortex, and then the last one is the combination between source and sink. Okay, so basically this combination, when the source and sink approach one another, so we call it as a doublet. Okay, so this is we can call it as a doublet. So when source and sink approach one another. Okay, so this is since it is still related to the source and sink, so basically the equation for the psi and also velocity potential, it is much related to the source and sink. Okay, not much related, basically it is similar to the source and sink. Okay, so recall that for the source and sink, psi or the stream function equal to m over 2 pi theta, and then for the velocity potential, v equal to m over 2 pi ln r. So this is for source and also for sink. Okay, so if for this kind of example, basically we use also use source and sink. Okay, so for example, for this point, this is source. This is source where the flow or the streamline is pointing outwards from the origin, while for the sink you can see it is pointing towards the origin, so it is sink. And then there are theta 1. Okay, so this is theta 1 angle, and then theta 2 represent for the source, and then this is common coordinate system for theta for the r. Okay, so to combine stream function for source and sink, we develop based on the psi or stream function. Okay, so psi equal to for negative m over 2 pi. Okay, so which one is negative? Negative is basically sink, so it is for theta 1, and then the source is positive, so it is negative minus with theta 2. Okay, so this is where we start to develop the equation for psi or stream function for source and sink. Okay, so for this theta 1, to develop the psi or stream function. Okay, now we only given the theta 1 and also theta 2. Okay, so to develop or to start develop, we start with tangent. Okay, so tangent equal to tangent for this angle. Okay, so tangent, rearrange this equation. Tangent equal to 2 pi negative 2 pi psi over m equal to tangent theta 1 or minus theta 2. Okay, so basically from this tangent theta 1 and theta 2 from basic from the trigonometric identities. So tangent theta 1 and tangent theta 2 basically equal to tangent theta 1 minus with tangent theta 2 minus with tangent theta 2 over 1 plus tangent theta 1 tangent theta 2. So this is from you just recall your trigonometric identity. You can Google the trigonometric identity for tangent theta 1 minus theta 2. So this is tangent theta 2. Okay, so from this from this tangent from this figure, okay, so from this figure tangent theta 1, okay, tangent theta 1 basically equal to tangent theta 1 is tangent is this line over this line. Okay, so basically to get tangent theta 1 from this figure, so this is P, this is theta, and then this is R, this is R1, and then theta 1. Okay, so tangent theta 1, okay, tangent theta 1 equal to this line. So to get this line basically equal to this R sine theta, and then this line, okay, so this line basically equal to R cos alpha, R cos theta minus with A. Okay, so R cos alpha, okay, so this is your, let's say this is your, from this figure, R cos alpha basically this line, okay, R cos alpha, and then we want tangent theta 1, so only this length for theta 1, so R cos alpha minus with this A. Okay, while for tangent theta 2, okay, tangent theta 2 for this angle, so this is tangent R sine theta, R sine theta over R cos alpha, okay, R cos alpha plus with R cos alpha here, and then plus with this length plus with A. So R cos alpha plus A. Okay, so you got tangent theta 1 and tangent theta 2. Okay, and then from tangent theta 1 and tangent theta 2 you just substitute substitute this tangent theta 1 and tangent theta 2 in this equation. Okay, you substitute, and then you will obtain tangent negative 2 pi psi after you substitute, you basically will get 2ar sine theta over r square minus a square. So after you substitute tangent theta 1 and tangent theta 2, you will apply a lot of trigonometric identity until you obtain this final result, which is 2ar sine theta over r square minus a square. And then from this we can obtain the psi or string function equal to negative m over 2 pi negative m over 2 pi tangent inverse this 2ar sine theta and then r square minus a square. Okay, so from this is after this is obtained after you apply the trigonometric identity and then finding the tangent theta 1 and tangent theta 2, simplify, and then you get this equation. But however, this equation is can be simplified based on the assumption, not assumption, because the concept of combination of source and sink mean that when we assume that the source and sink is approach one another. So there are A, for example, A for this case, A, when source and sink approach one another, so when source and sink approach one another, so this will be to this direction, and then sink will move to this direction. So A, the distance for source and sink, can be assumed very small a, so it can be 0. And then in order to approach one another, to get it approach one another, the strength of source and sink, you remember M, the strength of source and sink will be increased. Okay, so source M for the source and sink will be increased to some value, infinity value. So this simplification, this assumption will be used in order to describe more, or to obtain more simplified equation for the string function. Okay, so let's move to the next slide. Okay, so basically this is what have been discussed before, how to obtain tangent theta 1 and tangent theta 2. And then next slide, after simplify, we get this equation psi equal to negative m over 2 pi tangent to 2ar sine theta over r square a square. Okay, so next slide. Okay, so this is where we start to simplify the previous equation. Okay, so before this we got psi equal to negative m over 2 pi tangent inverse 2ar sine theta over r square minus a square. So from previous slide, psi basically equal to negative m over 2 pi tangent inverse 2ar sine theta divided by r square minus a square. Okay, so first we need we assume that there are small value of distance a. Okay, so since the tangent of an angle approach the value of the angle, very small angle, so we can just ignore that tangent inverse small angle so it is equal to negative m negative m 2ar sine theta over 2 pi r square minus a square. Okay, so you can cancel out 2. It is equal to negative mar mar sine theta over pi r square minus a square. Okay, so from this equation for psi, it still can be simplified, because as I mentioned in the first slide, when source and sink approach one another, okay, so the a can be assume a very small a. So when source and sink approach one another, okay, so a will be very small. Okay, so for this term, r over r square minus a square, so a is 0, and then this one will be only 1 over r. M is increased because in order to get this source and sink approach one another, M must be, the strength of source and sink must be increased. So this equation now become negative m a over pi sine sorry r. So this equation m a sine theta divided by pi r, okay, where this m and then this can be for this negative m over pi r can be assumed as constant, as can be it is equal to k, which is a constant for the strength of source and sink. Okay, so next slide. Okay, so when the so-called doublet is formed by letting the source and sink approach one another, a approaching 0, while increasing the strength m must be increased, so that the product of ma over pi, okay, so this one ma over pi is remain a constant. So in this case, since r over r square minus a square now equal to 1 over r, therefore the final equation for psi for the source and sink ataupun for the doublet, it is equal to negative k sine theta over r. Okay, negative k sine theta over r. Okay, so where k equal to ma over pi. So this k is called the strength of the doublet. Okay, and then now we obtain the psi, which is negative k over r sine theta. Okay, so the question is how to obtain the velocity potential. Velocity potential, which is phi. Okay, we only have psi, which is stream function. How to obtain the velocity potential? Okay, but since from the psi we can obtain the velocity, for example, for this case we can obtain tangential. For the source and sink, we can obtain the radial velocity. Okay, so source and sink only have radial velocity, not a tangential velocity. Okay, so recall your source and sink equation. So to obtain VR equal to 1 over R d psi over d theta. Okay, it is also equal to del v, velocity potential, over del R. But now we don't have the radial velocity, but we can obtain with the radial velocity by differentiate this psi with respect to theta. Okay, so differentiate d psi over d theta, you will obtain integrate sine, differentiate sine, you will get cos theta. So you will obtain negative k over r cos theta. Okay, so integrate differentiate psi with respect to theta, sin theta, differentiate, you will get cos theta. Okay, so now you get d psi over d psi over d theta. Okay, so we are equal to 1 over r, d psi over d theta equal to negative k r cos theta. Okay, k r cos theta, which is negative k r square cos theta. Okay, so to obtain this psi, okay, so from this relation dv, the velocity potential, dv over dr equal to vr equal to negative k r square cos theta. Okay, to obtain phi, we integrate with respect to r, so we'll get negative k r minus 1 over 1 cos theta. So the velocity potential of phi, basically it is equal to k over r cos theta. Okay, so this is for doublet, and then for psi it is equal to negative k over r sin theta, negative k over r sin theta. So this is equation for doublet. Okay, so next slide. Okay, so this is k over r cos theta. So this is how the streamline looks like when the source, okay, source and sink approach one another. Okay, so when source approach one another, so this is how the streamline looks like. It is like a concentric circle streamline. Okay, so that's all for the doublet, and then now we complete the basic plane potential flow, and then the summary can be seen here. summary of basic plane potential flow for the uniform flow, source and sink, for the free vortex, for the vortex and doublet. This is V, velocity potential, and then this is psi for stream function, and then the component of velocities or uniform flow. It is in rectangular coordinate system, source, sink and doublet in terms of cylindrical coordinate system. Okay, so that's all for today. See you in next video. Thank you.